Welcome everybody. Today what we're going to go ahead and cover is lipids part 3. What is the interaction between carbohydrates and lipids? So one of the questions is, does fat make you fat? Right? Well, this is a great quote by Bob Wolf. He says, availability of glucose largely determines the rate of glucose oxidation or use as fuel. But the availability of fatty acids does not determine the rate of fat oxidation. Fatty acid oxidation is regulated by the rate of intracellular metabolism of glucose. In short, he proposes an interaction between glucose and fat metabolism. We see this here from this study by Wolf, in which you look at basal levels of fat oxidation, followed by infusion of 4.2 grams of carbs per hour, then 17 grams of carbs per hour, and then 34 grams of carbs per hour. Notice that fat metabolism is lowering in a dose-dependent fashion. In fact, it's cut in half with just 34 grams of carbs an hour. Why is this the case? Well, we have to understand that when you ingest carbohydrates, it essentially raises insulin, or the insulin to glucagon ratio. That leads to a decrease in cytosolic AMP, plus an increase in pyruvate availability. The end result of that is an increase in malonyl-CoA, and malonyl-CoA inhibits the rate-limiting enzyme carnitine palmitoyltransferase 1, or CPT1. CPT1 is essential for transporting long-chain fatty acids into the mitochondria. So again, high CHO, high energy availability, high pyruvate, high malonyl-CoA inhibits CPT1, or carnitine palmitoyltransferase 1, and therefore inhibits long-chain fatty acids from being translocated into the mitochondria and being used as fuel. So it's not that fat makes you fat, really. If you look here, if you were to wake up and have breakfast and that were your fat, that was the food that you ate, on the left, fat metabolism would be high. But we take that same high-fat breakfast to the right and add in carbs, fat metabolism is low. So, what about de novo fat synthesis? In one study by Arslan, pretty classic study actually, they gave 4 days of carbohydrate overfeeding, so 50% extra carbohydrates. They looked at liver de novo fatty acid synthesis and fatty acid synthesis in the whole body. What they found was that fat synthesis increased to 170 grams per day. However, only 1 to 2 of those grams resulted from de novo fat synthesis. Now, what I want you to look at is this table here. Look at fat oxidation in the basal state. Look at it after day 1 of 50% carbohydrate overfeeding and day 4. Then look at carbohydrate at basal, day 1 and day 4. What you're seeing is that fat metabolism is literally completely halted, with oxidation being 0, and carbohydrate oxidation skyrocketing. Clearly, this shows the interaction between fats and carbs. So, a lot of people say, oh, if you eat too many carbs, it'll be converted to fat. But the evidence really doesn't suggest that de novo fatty acid synthesis contributes a lot to fat formation. However, what you can see here is a carbohydrate overfeed, and as you can say from days 0, 1, 7, and 14, you see that fat oxidation decreases. Okay? So what's going on is that you're just not oxidizing as much fat, and you're storing the fat that you consume. So sort of an overview of what we were talking about. If you have circulating fatty acids, if you have a high amount of carbohydrate, you get an increase in circulating fatty acids because they're not being oxidized, an increase in triglyceride accumulation in things like muscle. That's going to lead to insulin resistance, hyperinsulinemia, and that's going to lead to an increase in adipose tissue. So it's a vicious cycle. So why does high saturated fat diet in the presence of carbs lead to insulin resistance? Why is that the case? Why can't your cells respond as well to insulin and the ability to take up glucose? Well, fatty acid composition of skeletal muscle membrane closely affects the dietary composition. So if we look here at graph A here, or figure A, if you have a high amount of saturated fatty acids, the membrane packs tight together and it becomes rigid, and you can't take in glucose as readily. However, if you have unsaturated fatty acids, such as B, you would actually increase the fluidity of the membrane and insulin sensitivity. So it's imperative that you don't combine fats with carbs. It's definitely imperative that you don't combine saturated fats with carbs. So what about insulin resistance? Here we have a study where they had a low fat and a low carb group. The low fat group had 20% protein. 25% fat and 55% carbs, with less than 10% being saturated fatty acids. The other group had 30% protein, 10% carbs, 60% fat. No limitation on saturated fat. In fact, most of their foods came from meats and cheeses. Now, if you look here at insulin sensitivity being measured by fasting glucose levels, the low-fat group didn't. Actually, that's the opposite. The low-carb group. So where it says low-fat, or actually, excuse me. So this is insulin sensitivity. So essentially, you have low-fat. That didn't change. And then low-carb. Low-carb's insulin sensitivity actually increased. So even though saturated fats were high, when they weren't in the presence of carbs, insulin sensitivity increased. And we see here, you look at lipoprotein fraction, low carb actually went down, and low fat stayed the same. So here, what we have, what you're looking at is essentially B on this figure, change in plasma triglycerides. So what we have is the low carb versus the low fat group. The low carb are the black dots, and the low fat are the open triangles. Notice that triglyceride levels are lower in the low carb, but not the low fat group. Now this seems paradoxical because you're consuming more triglycerides, you're consuming more fatty acids. However, it's not a problem because carbohydrates are low and those fats are just being oxidized. And so we see a decline in plasma triglycerides. You know, today we're getting a lot of new studies. We used to think that fat was evil, that fat was causing all the disease that we see. This is looking at cardiovascular risk factors. So the more to the right each of these dots are, which are each individual studies, the greater the probability of cardiovascular disease. And what you're seeing is the impact of total fat intake on this. What you notice is that it's not having a significant impact. So total fat intake is not associated with cardiovascular disease, cardiovascular death. Same thing with saturated fat. We don't see that. If you look at the means, saturated fat is not associated with these issues, with these problems, with cardiovascular disease. However, trans fatty acids are. As you recall, basically what typically happens is you have the cis and trans form of fatty acids, and in the cis form, on the double bond, both carbons are on the same side of the double bond. However, on the trans form, the carbons are on opposite sides of the double bond, hence the term trans. And this is formed when you make things like when you hydrogenate, like unsaturated fatty acids, to things like margarine, with baked goods that are high in fat, French fries, things like that, ho-hos, Hostess cupcakes. But you notice that trans fats are associated with cardiovascular disease. So you do not want to ignore trans fats. You want those low in your diet. And again, that's from staying away from baked goods, cookies, Dunkin' Donuts, fried foods, etc. Now, even though, listen to this now, even though dietary fatty acids are not associated with cardiovascular risk disease, plasma saturated fatty acids are. That seems a little confusing, right? Let me say it again. Dietary fatty acids are not associated with cardiovascular disease. However, plasma fatty acids are. What this means is that we don't want elevated plasma saturated fatty acids. That's the problem. So what you're looking at here is plasma fatty acids, and you're essentially looking at plasma fatty acids in the blood. And what you notice is that you have the low carb group, which is blue, and the high carb group, which is red. Notice that plasma saturated fatty acids are higher in the low fat, high carb than the high fat, low carb group. And again, that's because they can be oxidized. So let's sum this up. Saturated fats, as compared to polyunsaturated in the presence of carbs, appear to increase insulin resistance and cardiovascular disease. However, high carbohydrate causes very little de novo fat synthesis. Okay. Fats in the presence of carbs, again, have low rates of oxidation, or thus steer towards storage. And finally, fats in the presence of low carbohydrates appear to have favorable effects on blood lipid profile and insulin sensitivity. This leads us to sort of think, maybe it's not the total fat in our diets that's the problem. It's what we're pairing those fats with. So if you have an athlete and they go to dinner, and they know the dinner is going to be fatty, at that point, they should just consume the proteins, the fats, and leafy green vegetables or vegetables, and stay away from the higher starchier carbs and the cake. It's the combination of those two that makes that fat stick and negatively impacts body composition. So just remember, throughout a day, what are you pairing your fats with? Are you pairing it with low carb or high carb? You know, in your high carb meals, how much fat do you have in those? Fat should be proportionally lower. That one concept right there can drastically transform your body composition and the body composition of your athletes. I'll see you next time.